The paper of the day is towards GPUs being mainstream in analytic processing. There have been a number of research proposals to use discrete graphics processing units, aka GPUs, to accelerate database operations. Although many of these works show up to an order of magnitude performance improvements, discrete GPUs are not commonly used in modern database systems. However, there is now a proliferation of integrated GPUs which are on the same silicon die as conventional CPU. With the advent of new programming models like heterogeneous system architecture, these integrated GPUs are considered first-class compute units with transparent access to CPU virtual addresses and very low overhead for computational offloading. They show that integrated GPUs significantly reduce the overheads of using GPUs in a database environment. Specifically, an integrated GPU is 3 times faster than discrete GPUs, even though the discrete GPU has 4 times the computational capability. Therefore, they develop high-performance scan and aggregate algorithms for the integrated GPU. Papers show that the integrated GPU can outperform a 4-core CPU with SIMD extensions by an average of 30%, that is up to 3.2 times, and provides an average of 45% reduction in energy on 16 TPCH queries. Papers use TPCH benchmark for evaluation. They pre-joined the TPCH dataset and ran queries on the materialized dataset, that's white table, using scans and aggregate operations. Let's look at the contributions. Paper implements an in-memory GPU database system by leveraging the fast scan technique, bit weaving, and the database denormalization technique, white table, a new method to compute aggregates on GPUs efficiently. Using this implementation, they show that the benefits of their approach for an important but admittedly limited class of scan aggregate queries. They find that the integrated GPU can provide a speed up of as much as 2.3 times on scans and up to 3.8 times on aggregates. They also evaluate their algorithms on 16 TPCH queries using the white table technique and find that by combining the aggregate and scan optimizations, the integrated GPU can increase performance by an average of 30%, that is up to 3.2 times, and decrease energy by 45% on average over a 4-core CPU. Thus, they conclude that it is now practical for database systems to actually deploy methods for GPUs in production settings for in-memory scan aggregate queries. With the proliferation of integrated GPUs, ignoring this computational engine may leave significant performance on the table. Let's talk PS score for this paper. Overall, this paper is a decent read, so it gets 7 out of 10 on readability. With 8 pages long, it scores 7 out of 10 on length. It's a research prototype with decent description, so that makes it 7 out of 10. Its industry value and learning meter is unproven, so it gets 7 out of 10 on each. Overall PS score of 7 out of 10.